where the specific surface area, the pore surface area is important. Fineness? No, we're talking about not about the cement, right? We're talking about the cement paste. So we're talking about the surface area of the pore. You look at MIP, right? You have all these different pores. Through MIP, you find the pore size and total porosity. Did I ever talk about surface area in MIP? Is pore surface area important? Yes or no? No? Then I will skip. But I'll have to. Somebody say yes so that I can say the answer. Right? No, but this is all beyond that point. We have left that station. That train has left the station. Okay, we are moving on. Calcium hydroxide is formed, it's sitting there. Forget it. You have a hardened paste. It has a certain pore structure. Why am I interested in the surface area of the pores? So what? After volume, what will you do? Surface area of pores. Think about it. You will know the answer. It's for a property, not for fun. Surface area of pores. What do you have inside the pore in concrete? Pore solution, water. When you have a surface area and when you have water inside, what property is surface area influencing? Durability generally, but give me more specifics. Evaporation. Evaporation is a function of surface area. What happens when water in the pores, in the small pores, start to evaporate in a hardened cement paste? What is the property that you get? I heard that. What is that? Shrinkage. And what will happen when concrete shrinks? Cracks. See here? This directly links to your determination of shrinkage in concrete. Right? Because pore surface, there's absolutely no other way to determine the pore surface area. You can do BET. BET kind of will give you some numbers, but you can't be sure because you're crushing in, you don't get the entire pores. This is the only way. And so, again, see, combination of some techniques, but the technique by itself is not capable of doing it. That's why I want to bring this up. The technique by itself is not capable of giving you the answer. You have to throw in some smart mathematics also with the technique. Now you get, and there's no software really will do it, so you have to write your own code. But it's very simple. I mean, how difficult is to take derivative of a curve, of a function, right? So you see how it is? You get the line. All you have done is through the simple idea of throwing lines of different lengths into these faces, find out what's the probability of the line lying in one face, draw the curve for that. That's called the 2-point probability function. The tangent at the origin will give you a point that it intersects with the plateau. That is a critical length. Using critical length, you do the critical size. You take the first derivative of the curve with respect to length, equate it to 0. What you get is, or take the limit to 0, what you get is 1/4 of the specific surface area of the pores. Again, I skipped a lot of math between this and this, but that's okay. You don't need it. Okay? But that's what happens. See how powerful these things start to become? See how interesting now you can start to find out newer and newer things within your structure. Okay, microstructure creation. Now I want to bring, I want to start talking a little bit about this in the next